Now we are starting anions of concentrate group, that is called group second anion. So concentrate sulfuric acid group anion. The anions of this group liberate acid peppers or gases with concentrated H2SO4. Now in this group we are placing the anion is, first one is Cl negative, that is called chloride. Second is bromide, that is Br negative. Third one is I minus, means iodide. And fourth becomes nitrate, that will be NO3 negative. This one is called nitrate. So these four radicals or four anions are placing in the group of concentrated H2SO4. Now we will discuss one by one. So first we draw a table. Now we are putting first the table, this is experiment. Second is observation. And third one is inference. So in the first step we are taking a salt and adding concentrated H2SO4 to the salt. So this test tube, this test tube contain chloride containing salt like ammonium chloride or any other salt which contain chloride. So we are adding this concentrated H2SO4 in this salt, and the observation is that when we are adding concentrated H2SO4 in this salt and if this salt contain Cl negative, means chloride ion, then after the reaction the product will be formed, that will be when ammonium sulfate plus HCl. So if we are having that HCl gas evolve from this test tube, and this HCl gas having pungent smell. So if pungent smelling gas evolve from HCl, so a pungent smelling gas evolve from this test tube, that may be HCl. Now we can say that this salt contain chloride radical may be. So the inference is this salt contain chloride may be. Now in the second step we are confirming of this salt. So now we are using confirmation test. For confirming of this salt or this Cl negative ion, first we are taking a glass rod, this type of glass rod. This glass rod dipped in concentrated HCl solution. Now we are applying this glass rod on the mouth of the test tube. The glass rod dipped in liquor ammonia, not concentrated HCl, since concentrated HCl already evolving from test tube. So this glass rod dipped in NH4OH. This NH4OH is called liquor ammonia or ammonium hydroxide. So this one is glass rod. This glass rod dipped in liquor ammonia and apply on the mouth of the test tube. So for example, this one is the test tube and HCl gas evolving from this test tube. This HCl gas when we are applying this glass rod on this test tube. So after the reaction between NH4OH and HCl, it gives the white dense fume of NH4Cl. Here is the white dense fume of NH4Cl. It gives NH4Cl and NH4Cl gives white dense fume. So the picture is that like this one is when applying this experiment, then here is the salt and here is the dense white fumes appears, and these dense white fumes is due to this NH4Cl. So if dense white fumes of NH4Cl are observed, then we can say that the salt contain Cl negative definitely. So here is the observation is white dense fume of NH4Cl. White dense fume of NH4Cl, and we can say that the salt contain Cl negative confirmed. So here is this one is the confirmation test for Cl negative. We are taking another confirmation test for the confirmation of Cl negative. That is the very popular test or very specific test for Cl negative, that is called chromyl chloride test. So the test is called chromyl chloride test. In chromyl chloride test, we are taking solid salt. This salt is chloride containing, and in this salt we are adding solid potassium dichromate, that is orange in color. Solid potassium dichromate K2Cr2O7, that is taken in the solid form and that color is orange. So in a dry test tube we are taking salt and some amount of solid potassium dichromate, and in this test tube we are adding concentrated H2SO4. So after the reaction, what happened when we are taking this test tube? This one is the salt which contain chloride containing salt. This one is the salt chloride containing like ammonium chloride or any other salt. Plus now we are already taken this test tube in potassium dichromate K2Cr2O7 in solid form, and third one is concentrate H2SO4. Add to the concentrate H2SO4. So the observation is that it gives orange-red fumes of chromyl chloride. So after the reaction, this test tube gives orange-red fumes of chromyl chloride, that is CrO2Cl2. That is called chromyl chloride, and gives that fumes is red brown. Sorry, orange red, not red brown. Gives the color of fumes of chromyl chloride is orange red. So orange red fumes are appears of the chromyl chloride. So we can say that this salt contain maybe chloride ion, Cl negative. So we can say that Cl negative. Now this experiment continue, and in the second step, the vapors of chromyl chloride, this test tube which contain this vapors is chromyl chloride, that is CrO2Cl2. These vapors of chromyl chloride pass through another test tube which contain sodium hydroxide solution. These vapors of chromyl chloride pass through another test tube. This test tube contain NaOH solution. So these vapors of chromyl chloride pass through in this NaOH solution. So after the reaction between chromyl chloride and NaOH, we get an orange solution of sodium chromate. Now in this test tube we are having a yellow solution of sodium chromate, Na2CrO4. So we can say that will be Cl negative. Now in the third step, the test tube which contain chromyl chloride, the test tube which contains sodium chromate. In the third step, the test tube which contain yellow solution of sodium chromate, NO2CrO4. In that test tube we are adding lead acetate solution. So in that test tube we are adding lead acetate solution, and the observation becomes after the reaction between lead acetate and sodium chromate, we are having a yellow precipitate of lead chromate, PbCrO4. It gives the precipitate. Since sodium chromate is soluble but lead chromate is insoluble, but color of the solution of sodium chromate and precipitate of the lead chloride both are same. So here is the addition of lead acetate, then we get a yellow precipitate of lead chromate. So we can say that this salt contain Cl negative or Cl negative is confirmed. So in these three steps, chromyl chloride test is completed. Now we are performing third confirmation test. That one is called silver nitrate test. That is silver nitrate AgNO3 test. In the silver nitrate test, the test tube which evolving HCl gas, we are adding silver nitrate solution to the test tube, and after the reaction we get a white PPT of AgCl, white precipitate of silver chloride AgCl, and this PPT is insoluble, or this which is insoluble in which is soluble in liquor ammonia, that is NH4OH. So if this process is happen, then we can say that Cl negative is confirmed. So we are taking these three tests for the confirmation of Cl negative ion. Now we are taking another test for the Br negative. We are taking a salt and adding concentrated H2SO4 to the salt. If this salt contains Br minus, suppose we are taking a salt of sodium bromide NaBr, then after the reaction we are getting Na2SO4 plus HBr. So when we are taking a salt and adding the concentrated H2SO4, the salt is NaBr, adding the concentrated H2SO4, then what happen? First, these two salt means NaBr and adding concentrated H2SO4 react, and after the reaction it gives HBr plus Na2SO4. But after is that what happen? As soon as this HBr is formed, concentrated H2SO4, which is a stronger oxidizing agent, further react with this HBr, and finally concentrated H2SO4 converted to Br2 for HBr, means concentrated H2SO4 further oxidized HBr to Br2. So finally we are getting a fumes of Br2, not we are obtaining HBr like HCl. In the first case we are having the HCl, but HCl is not further oxidized by H2SO4, but in that case HBr is further oxidized by H2SO4. So we are finally having a fume orange brown fumes of Br2. So the inference is test tube evolve fumes of Br2. This color is orange brown. So if these types of fumes appear, then we can say the salt contain Br negative maybe. The salt contain Br negative maybe. Now we are applying confirmation test, confirmation for the salt. For confirming the Br negative salt, we are taking two types of confirmation test. First is silver nitrate test. In the silver nitrate test, the test tube which are evolving Br2 gas adding to the silver nitrate, this test tube, and after the reaction we are getting a precipitate of EGBr. EGBr precipitated. This color is pale yellow, and this PPT is insoluble or sparingly soluble in NH4OH. This is slightly soluble in NH4OH. So we are saying the salt contain, or in the salt Br negative is confirmed. Now we are taking another confirmation test, that is called layer test. In the layer test, the test tube which are evolving orange color, light orange color or brown color Br2 gas. This test tube evolving Br2 gas. We are adding organic solvent, so organic solvent like chloroform or CCl4 or benzene or carbon disulfide. We are adding any non-polar organic solvent. So when we are adding non-polar organic solvent to the test tube, then the vapors of Br2 is completely dissolved to the organic solvent. Since Br2 is non-polar and organic solvent also non-polar, so in the test tube we are having two layers. In the test tube we are having two layers. The first layer is the polar solvent or polar layer. This one is the polar layer, and the another layer is non-polar layer. This one is the non-polar layer. In this non-polar layer we are having Br2 plus benzene. We are adding non-polar solvent like benzene, then complete Br2 dissolve in benzene and form a layer, upper layer. The formation of this layer depends upon the density of this solvent. If we are having the benzene or taking the benzene, and then this complete Br2 dissolve in benzene, and since density of the benzene is lighter, so this layer, so the layer formed in the upper layer. So the upper layer indicate that this contain Br negative, and if we are using dense solvent like chloroform CCl4, then this layer form in the lower part. Now this layer test indicate that this salt contain Br negative. So here is the Br negative which confirmed.